Hello, my dear students. Myself S. Devi, Assistant Professor, Department of Artificial Intelligence and Data Science. Today we are going to see about interprocess communication. Interprocess communication is the way in which the process communicate with each other is known as interprocess communication. The process executing concurrently in the operating system may be either independent process or a cooperating process. The cooperating process require an interprocess communication mechanism that will allow them to exchange data and information. So we will see what is independent process and what is cooperating process. An independent process is a process if it cannot affect or be affected by the other process execution in the system. A process which cannot be affected by other process execution in the system. Any process that does not share data with any other process is independent. Cooperating process. A process is cooperating if it can affect or be affected by the other process execution in the system. Any process that shares data with other process is a cooperating process. So there are three methods for communicating between the process. That is, first one is shared memory, pipe and semaphore. The shared memory is nothing but a region or a portion of memory that is shared by cooperating processes established. A process can then exchange information by reading and writing data to be shared region. You see the diagram that represents process A and process B is in main memory, and the process A and process B that shares a common location known as shared memory. The system calls are required only to establish shared memory regions. Once shared memory is established, all access are treated as routine memory access and no assistance from the kernel is required. Process ensure that they are not writing to the same location simultaneously. So we will see an example for producer consumer problem. A producer process produces information that is consumed by a consumer process. One solution to the producer consumer problem is shared memory to allow producer and consumer process to run concurrently. A buffer memory is used as a shared region where the producer fills the item and the consumer that uses or empties it. A producer can produce one item while the consumer is consuming another item. The consumer does not try to consume an item that has not yet been produced. The advantage of this is shared memory is faster than message passing. No kernel assistant is required. The disadvantage of this shared memory is data is shared by all users. Shared memory suffers from cache coherence issues which arises because shared data migrates among several caches. There are two types of buffering: unbuffered, unbounded buffer and bounded buffer. In the case of unbounded buffer, no limit on the size of the buffer. In the case of bounded buffer, that is a fixed buffer size. We will see the next type, which is used for communication between the process that allows interprocess communication. The pipes are a type of IPC, interprocess communication technique, that allow two or more processes to communicate with each other by creating a unidirectional or bidirectional communication channel between them. A pipe is a virtual communication channel that allows data to transfer between processes either one way or two way. The pipe can be implemented using system calls in the modern operating system, including Linux, Mac OS and Windows. Here we are considering the same example, that is producer consumer problem. That is the unidirectional flow. Data flows in one direction only. A process writes to one end of the pipe and the another process reads from the other end. The producer consumer model, this is standard communication pattern for pipes where one process produces data and other consumes it. The byte streams of data is used. The data in the pipe is treated as a stream of byte, meaning that no inherent knowledge of message boundaries. FIFO concept is used here. The pipe operate on FIFO principle like a queue. The second one is pipes. That is, we are going to see the pipe is implemented with the help of an array which indexes of two sizes 0 and 1. The file descriptor which pipe is created, the system calls returns two file descriptor, one for reading from the pipe and another for writing to the pipe. FD is nothing but it is an array. It's of size 2 which holds two file descriptors after the pipe is created. FD of 0, that is the array with an index value 0, is mainly used for reading from the pipe. That is the readent. FD of 1, that is the index value 1 of an array, is used for writing purpose. That is the writent. So this is the diagram as I told you. 0, F of 0 is the file descriptor which is used for reading from the pipe, which is considered as a readent, and F of 1, the file descriptor, is used for writing to the pipe, which is the writent. There are two types of pipe, ordinary pipe and named pipe. Ordinary pipe, also known as unnamed pipe or anonymous pipe. Ordinary pipe are the fundamental mechanism in operating system for enabling communication between process. They are also known as anonymous pipe or unnamed pipe. Ordinary pipes allow simple one-way communication between parent and child process. They are widely used in Linux system for data exchange in pipelines and process communication. It is easy to implement and easy to understand, but it has only limited to related process and one direction. Already I told you the mechanism that which end is used for read purpose and which end is used for write purpose. It is stored temporarily in kernel buffer. One process write data into the pipe and the other reads from it. Next we will see the named pipe. The mechanism behind the named pipe is communication can be bidirectional and no parent-child relationship is required. Once a named pipe is established, several processes can use it for communication. The named pipe is also known as FIFO. It's a special type of file used for unidirectional interprocess communication, unlike ordinary pipe, which can use to establish two-way communication between two unrelated programs. Multiple processes can access a special file for writing and reading like an ordinary file. To achieve bidirectional communication, typically needs to set up two separate ordinary pipes, one for each direction. So we will see the third type, which is semaphore. Semaphore is an integer variable that controls access to the resources. The mechanism of semaphore is a semaphore uses an integer counter. There is two operations performed: semaphore, wait and signal. The wait of P means it decreases the semaphore value. If the value is greater than 0, the process continues. If the value is less than 0, the process is blocked. That is, the process can access the semaphore value. The signal. Next, the function signal increases the semaphore value, wakes up one of the block process, if any. Waiting and signal operation is to control the number of processes that can access a critical section of code or shared resources. If one process modifies the semaphore value, no other process can modify the semaphore value at a time. So this is the function of wait, which is denoted by the P symbol. The function is used to test the semaphore value. It decreases the semaphore value. If the value becomes negative, the process is blocked. Next function is signal. It denoted by V symbol. It gives signal to the waiting process to access. If the value is negative, used to increment the semaphore value, it activates a process block on the semaphore. Example, common resources to be accessed is given to the critical section. When a process is waiting to use the resources, it will give wait. That is, the wait function is invoked here. The semaphore value is decremented. The process starts using the resources. After using the resources, the signal function is called, which increments the semaphore value so that the process waiting for the resources can access the resources. The advantage of the semaphore is semaphore helps prevent data corruption because only one process can access that semaphore value at a time. Semaphore ensures proper synchronization between concurrent processes. Thank you.